Hello dear students, this is Vishal sir from Ikra High School. Today we will study Chapter 2, Acid, Bases and Salts, Standard 10, NCERT syllabus. Let's start with reading the lesson. You have learnt in your previous classes that the sour and bitter taste of food are due to acid and bases, respectively, present in them. If someone in the family is suffering from a problem of acidity after overeating, which of the following would you suggest as a remedy? Lemon juice, vinegar or baking soda solution. Which property do you think of while choosing the remedy? Surely you must have used your knowledge about the ability of acid and bases to nullify each other's effect. Recall how we tested sour and bitter substance without tasting them. You already know that acids are sour in taste and change the color of blue litmus to red, whereas bases are bitter and change the color of the red litmus to blue. Litmus is a natural indicator. Turmeric is another such indicator. So dear students, the basic properties of acid and base are: acids have sour in taste, it turns blue litmus red, it reacts with some metal to produce hydrogen gas and dissolves carbonate salt releasing carbon dioxide. In the same manner, bases have their own properties. They are bitter to taste, turns red litmus blue and are slippery to touch. The diagram over here shows the acidic nature and the basic nature of both the substances. Also, there are indicators which detect an acid and a base through color or their smell. Here you can see the litmus paper. The litmus paper helps us to detect an acid solution and a base solution. Acids, that is on the left hand side, turns blue litmus to red, while bases turns red litmus to blue. This is one of another indicator, phenolphthalein. It shows a color like this when it detects an acid or base. This is one another indicator, methyl orange, which turns acid to this color and a base to yellowish color. Then we have olfactory indicators. That means the indicators which detect the smell or the odor. So, litmus is an indicator which is natural. Turmeric is also natural. Both of them detect acid and base according to their change in color naturally. They are obtained from nature. While chemical indicator or synthetic indicators are there which also detect acid and base according to the change in color are methyl orange and phenolphthalein. Then there are olfactory indicators. Some substance whose odor changes in acidic or basic media are called olfactory indicators. They are vanilla essence, onion and clove oil. Now let's study the acid and bases reactions. First, acids and base react with metals. Let's read the activity 2.3. Set the apparatus as shown in figure 2.1. Take about 5 ml of dilute sulfuric acid in a test tube and add few pieces of zinc granules. Here you can see acid and metal. What do you observe on the surface of zinc granule? Normally we observe some bubbles past the gas being evolved through the soap solution. Why are bubbles formed in the soap solution? Take a burning candle near a gas filled bubble. What do you observe? Repeat this activity with some more acid like hydrochloric acid, nitric acid and acetic acid. The metal in the above reaction displaces hydrogen atom from the acid as hydrogen gas and forms a compound called salt. So, zinc, a metal, reacts with any of the acid, it evolves hydrogen gas and the leftover is a compound, a new substance called salt. The salt is neither an acid nor a base. Thus, the reaction of the metal with an acid can be summarized as acid plus metal gives salt plus hydrogen gas. How do metal carbonate and metal hydrogen carbonate react with acid? Let's read another activity. Take two test tubes, label them as A and B. Take about 0.5 gram of sodium carbonate in test tube A and about 0.5 gram of sodium hydrogen carbonate in test tube B. Add about 2 ml of hydrochloric acid. What do you observe? Pass the gas produced in each case through lime water. What happens when acid reacts with carbonate or hydrogen carbonate? The reaction will be like this. In test tube A, sodium carbonate reacts with HCl, which gives sodium chloride, water and carbon dioxide. So when acids react with carbonate or hydrogen carbonate, it evolves carbon dioxide gas. The milky solution shows the presence of carbon dioxide. On passing excess carbon dioxide, the following reaction takes place. Still, if you go on passing carbon dioxide to the same solution, you will get CaHCO3 twice, and that is the milky solution becomes colorless. Limestone, chalk and marble are the forms of calcium carbonate. All metal carbonates and hydrogen carbonate react with acid to give corresponding salt, carbon dioxide and water. Now how do acid and base react with each other? Let's read another activity. Take about 2 ml of dilute sodium hydroxide solution in a test tube and add 2 drops of phenolphthalein solution. What is the color of the solution? Here, if you have noticed, we are using an indicator, phenolphthalein. A synthetic indicator means an indicator which was made in laboratory to detect acid and base. Add dilute hydrochloric acid to the above solution. Is there any color change for the reaction mixture? What is the color of phenolphthalein change after addition of the acid? Now add a few drops of sodium hydroxide to the above mixture. The pink color of the phenolphthalein reappears. Why do you think this has happened? So, there is a transformation of color from pink to colorless and again to pink. In the above activity, we have observed the effect of base is nullified by acid. So, whenever acids reacts with base, it nullifies both the effect, the acidic effect and the basic effect. And what is obtained? Salt and water is obtained. So, the reaction between an acid and a base to give salt and water is known as neutralization reaction. Base plus acid, or you can say acid plus base, gives salt and water. Reaction of metallic oxide with acid. Take a small amount of copper oxide in a beaker and add dilute hydrochloric acid slowly while stirring. Note the color of the solution. What has happened to the copper oxide? You will note the color of the solution becomes blue-green and the copper oxide dissolves. The blue-green color of the solution is due to the formation of copper chloride in the reaction. The reaction between metal oxide and acid can be written as metal oxide on reacting with acid gives salt and water. Since metallic oxide react with acid to give salt and water, similar to the reaction of base with acid, the metallic oxide are said to be basic oxides. So whatever we obtain in this reaction is called basic oxide. Reaction of non-metallic oxide with base. You saw the reaction between carbon dioxide and calcium hydroxide in activity 2.5. Calcium hydroxide, which is a base, reacts with carbon dioxide to produce salt and water. Since this is similar to the reaction between a base and acid, we can conclude that non-metallic oxide are acidic in nature. What do all acid and all base have in common? All acids have similar chemical properties. Let's study about this similar chemical properties. The first one, all acids generate hydrogen gas on reaction with metals. Hydrogen seems to be common in all acids. Let's study an activity to study some more properties of acids. Activity 2.8, take solution of glucose, alcohol, hydrochloric acid, sulfuric acid, etc. Fix 2 nails on a cork and place the cork in a 100 ml beaker. Connect the nails to the 2 terminals of the 6-volt battery through a bulb and a switch as shown in figure 2.3. Now here you can see this is a rubber cork, that means it's an insulator. The 2 nails doesn't touch each other, but they have a common surrounding, that is a dilute hydrochloric acid, sulfuric acid, alcohol or glucose, any one of them. Now pour some dilute hydrochloric acid in the beaker and switch on the current. Repeat with dilute sulfuric acid. What do you observe? Repeat the experiment separately with glucose and alcohol solution. What do you observe now? Does the bulb glow in all the cases? The bulb will start glowing in the case of acids. But you will observe that glucose and alcohol do not conduct electricity. Glowing of bulb indicate that there is a flow of electric current through the solution. The electric current is carried through the acidic solution by ions. So acid conduct electricity. And why does acid conduct electricity? Because it releases ions. Which ions? Acid contains hydrogen ion as cation and anion such as chlorine in hydrochloric acid, nitrate in nitric acid, sulfate in sulfuric acid, and CH3COO in acetic acid. Since the cation present in acid is hydrogen, this suggests that acid produce hydrogen ion in the solution which are responsible for their acidic nature. So the acidic nature of an acid is due to the presence of hydrogen ion in any solution. What happens to an acid or a base in a water solution? Let's read the activity 2.9. Take about 1 gram of solid sodium chloride in a clean and dry test tube and set up the apparatus as shown in figure 2.4. Add some concentrated sulfuric acid to the test tube. What do you observe? Is there a gas coming out of the delivery tube? Test the gas evolved successfully with dry and wet litmus paper. The litmus paper, again here it is used as an indicator for testing acid or base. It will turn red when it's acid, it will turn blue if it's base. In which case the litmus paper changes color. On the basis of the above activity, what do you infer about acidic character of the dry hydrochloric acid and hydrochloric solution? There are two forms of hydrochloric acid. One is a dry hydrochloric acid gas, another is a hydrochloric solution, that is a solution of water where hydrochloric acid is added. This experiment suggests that hydrogen ions in hydrochloric are produced in the presence of water. The separation of hydrogen ion from hydrochloric molecule cannot occur in the absence of water. So the release of hydrogen ion is only possible if it's an aqueous solution. If it is not an aqueous solution, that means it is a concentrated hydrochloric solution, a dry hydrochloric gas, it does not evolve hydrogen ion. Hydrochloric acid plus water gives hydronium ion plus chlorine. So the hydrogen ion does not exist singly, it forms a molecule with water and becomes hydronium ion. Hydrogen ion cannot exist alone, but they exist after combining with water molecule. Thus hydrogen ion must always be shown as H plus aqueous or hydronium ion. We have seen that acid gives hydrogen ion or hydronium ion in water. Let us see what happens when a base is dissolved in water. When a base is dissolved in water, sodium and hydroxide ion is formed. So bases produce hydroxide ion instead of hydrogen ion. Potassium hydroxide when reacted with water produces potassium plus hydroxide ion. Same way magnesium hydroxide produces magnesium plus hydroxide ion. Bases generate hydroxide ion in water. Bases which are soluble in water are called alkalis. Now as we have identified that all acids generate hydrogen ion and all bases generate hydroxide, we can view the neutralization reaction as follows. Acid plus base gives salt and water. Here in acid hydrogen ion is released, in base hydroxide ion is released, which on reacting becomes water. The process of dissolving an acid or base in water is highly exothermic one. Care must be taken while mixing concentrated nitric acid or sulfuric acid with water. The acid must always be added slowly to water with constant stirring. If water is added to concentrated acid, the heat generated may cause the mixture to splash out and cause burns. Glass container may also break due to excessive local heating. Look out of the warning sign on the can of the concentrated sulfuric acid and on the bottom of sodium hydrogen pellets. Mixing an acid or base with water result in decrease in the concentration of ion per unit volume. Such process is called dilution. and the acid or base is said to be diluted. So when you add an acid or base to water, its concentration decreases and the product that you obtain is dilute hydrochloric acid or dilute sulfuric acid or dilute sodium hydroxide. Thank you, children.